Hello, teacher. And now I want to introduce my deep learning project. My project is the image caption generation. My name is Pham. I'm from AI and robots major, and I study in Medical University. So now we introduce my first. I want to introduce my project. I second I talk about my approach uh, in my project, and third is conclusion, and the last one is demo my project. So let's introduce my project. As you can see, as you learn in the AI and computer vision domains have is doing the many tasks like object detection and object recognition by using the CNN models. It's in here is the VGCs are 16, and the natural language processing domain. It's various applications like personal assistant and translation by using the recurrent neural networks like LSTM, attention, and recently it's transformer ability exploring vision. So if you combine the computer visions and natural language processing, what would uh, what should we do? So the image with many captions in here. The image is the right left hand side with the five caption, and we call it in the image caption generator by using the computer vision, using the model CNN to extract features in image and natural language processing by handle textures by using the text context in the sentence in the caption, and we can get together, and that is image caption generator do. And we have a many applications in the by using image caption generator. um, for example, we use Facebook in social media. Platform like Facebook can infer directly from the image where you are and what you wear, and more importantly, what you doing also. And next, I will talk about my approach in the problem by using the the CNN, RSTM, CNN, RNNs in my model, and how data sets perform. So that data sets in here, we use Flickr 8K data sets, which have 8,000 image with 5 captions for each image. And the larger data sets is Flickr 30K datasets and MS Coco. Um, the caption will for each image is 5 caption. As you can see in the picture, the dog, the picture of dog. Uh, there are caption, 5 caption with more context and more meaning in the picture. Here you can see the dataset with 8,092 multiplied with 5 captions corresponding to um, 8,000 corresponding to X image in the dataset. But there's many words that appears more times, especially prepositions. So we clean the descriptions and summarize vocabulary to 8,579. It's many words appearing, and that's the top 15 most frequently appearing words that the in, the, on, is, and, or doesn't know what its meaning. And the last one is the list 50 most frequently appearing words. That is a statistic. So next we have to we have to talk about the prepare image data. CNN's model to extract features and remove last layers and use for predicting. So this layer will be classify what's the object and the names of object or something. Um, we pre-process image, calculate and the save feature, and with uses VCs 16 and with approximately 1,000 145 million parameter, and input size with 224, and output of this test is 496. We save the feature in the file in the pickle file because we predict 100 image it take a long time with the GPU in collab, and we have to use more time, and so we save file feature in a file a name file feature. We also prepare text data. First of all, we lost on description and clear dictionary mapping with dictionary, and we create a vocabulary. That's the 800 8,000 and 760 63. And clean description, we convert all words to lowercase, remove all punctuation, and removes words one character long, and remove words with numbers. As you can see here, the picture, the below feature is below feature with the raw data, and before we pre-process text data, we got the caption with cleaner. So, and we load data and prepare to training. So we're training with 6,000 data evaluation, and test is 1,000 data or 1,000 image, and combined with the text respectively. The caption, and we read from file because we save the caption description before cleaning up by file, and we add the start sequence and end sequence to move on for the model predict. And image feature, we also read from file feature pickle. So we encode the data. Another text data is very important to the recurrent neural network because as you can see here, we convert the description to list of words and use a tokenizer, and you can see tokenizer is very clearly to understand that we separate the sentence to separate sentence to into 8 words. This words in sentence, as you can see, it's 5 methods in tokenization. We map words for we map from words for the vocabulary to integer, like encoding, like on hot encoding, but and next we calculate vocabulary size and we compute the maximum caption length. It's important to put in the layer embedding. So next we divide model. AI is introduced in the first slide, and in the first introduction slide, we have three stages and three blocks. First of all, we extract feature extractor. That is the model pre-trained CNN. To extract feature image to get a 1D vector. And next, we have a sequence processor. That's uh, that's input is the caption descriptions, and the next is also the 1D dimensional the vector feature, and we concat with the image feature and put in decoder. Decoder like fully connected a dense layer, and so we predict the caption of the image, caption description of image. So as you can see here is this model we plot model VGC as 16 and the RSTM architecture. The here in the VGC 16 we get we have a 1D dimensional 1D dimension a vector feature. We put and we downscale down symbol to the 20 256 um, vector feature, and also with the air stamp and put in the dense layer. We concat two vector feature and push in the fully connected or dense layer, and we predict. We also we predict the output model with the 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 vocabulary size, and we ask must we source the we source index in the a vector with the 7,000 7,000 and 1,500 and 500, and the total parameter is approximately to 5,000 and 600. And we fix model with 10 is pop, and we receive all lost. We case sequence to x1 is meaning the image feature, x2 is the a text feature, and y is the cultures. Is the and data generator we use in this model to avoid the RAM and CPU limits, avoid out of memory, and we also suffer data. The accuracy, and we don't use accuracy, and we just observe lost curve, and the model gets overfitting as the 1 or 2 and 2 epoch. Maybe it's not good. So the average model auto maturing express its model is by quantity using it BLE use the lingual abbreviation under study score, which indicates how the similar the candidate text in this model is a caption, predict caption, and predicted caption is to the reference text, which values closer to one representing more similar text. Yes, it's a formula to formula of the Beasley use, maybe B else use a score, and we average in this my model. We get a BLEUs one. We get approximately 0.6, and the second and the third is quite small. And we generate caption, and we test in the test set. So you can see here the caption in the picture. You can see it's maybe it's not quite good. At the picture in the left hand side, but in the picture in the right hand side it may be wrong, maybe wrong in some feature, but that's okay. That's okay. So to collect, uh, and before I do project, and I do projects, I have some conclusions, and caption generation is challenging. We obtain quite good result, but it's very still there are many mistakes. And get caption on the stable image, but you rewrite is continuous. Continuous is it need to the model is very fast to detect, or fast to generate the caption in real life. Improvement we change model architecture. Maybe I use in some models, CNN or models for object detection, removes more words from vocabularies by improve the caption in very incorrect, increase type data set. Maybe you flicker 30 and implement attention correctly, and every people with the beam search. And also I using object detection model like factor RCNN or Zolo via V5 and Act. I plot to RNN plot with recurrent neural network or attention mechanism uh, or, transformer to generate the caption in real life. So now I'm introduce my demo. Okay. Here's my code for demo in my project. It's normally I use the use the Keras from TensorFlow API for using for prepares a code deep learning. I have a extract features by image, and whenever words for ID like convert to words for ID, and next we'll generate description. Yeah, first we create sequence, hash sequence, and we dig the worst, and we predict next worst, and by using sequence model, and we recognize like is I have said Markland we calculate is 34. A model we train model, and we get a model with a model 5 because it's good. And next I will show you my real-time different real-time. My computer is um, very weak, so it's run very slowly. It's, You can see here. Um, the model is very large, and we use VZ50 that the prediction is not fast, and we get more memory to run a system. So it's maybe, as you can see. Oh, maybe this model will we have the more system, more more RAM for using system. But I also run in my computer. Will test in some image. That's a generator caption, but you can see it is not good. It's not good. Also, you can see the bar is swimming trapped. A swimming underwater. You can see here. Here is have a water, and here the boys. There's some boys, some children. Maybe model will have to train with more data tests and with more the mechanism architecture model to improve my model and generate the captain correctly. So finally, thank you for watching, and thank you for hearing my presentation. I hope you like it.